so.
We got it, right?
On a test, does
No.
anyone ever? All right, guys, so graph of velocity.
That's such a good idea.
So you have velocity. We want to find, oh, and it says the initial position. So another way to write this would be s of 0 equals 4. So we want to find where the particle is at the end of the trip. So on the first page of our notes for chapter 7, you had like a bunch of different formulas and information about particle motion. It says on there, if you want to find the final position, it's initial plus the displacement. Oops, that's not supposed to. How do you find displacement? It's the antiderivative or the integral of velocity. Well, exactly, because we don't have an actual function to do the integral. So what we do is we do the area of the triangle and trapezoid. I actually just wrote in the areas here. This one is 9/2. I wrote this one in negative because it goes below the x-axis. Okay, anytime it goes below the x-axis, we count that as negative. I did a trapezoidal region, 1/2 times the 1/2 times the height. The height is 3, and then base 1 is 3, base 2 is 1. So that's, what do you mean?
Sorry, can you explain the
It's
travel?
1/2 height base, 1/2 base 2.
This I got. It's 1/2 times 3, and then base 1 plus base 2.
Oh, okay.
So you get 6.
Thank you. Yeah, okay. I see.
Okay? So does that make sense? We have 4 plus 9/2 minus 6 plus 2. You get 9/2. Now for the total distance traveled, whenever we're talking about a total amount, we want to just make everything positive. So basically, and we don't use initial condition. It's just absolute value of velocity under the integral, in the integral. So basically, anytime it has a negative velocity, we just make that positive. Good?
One
Does
part, one
the
part.
practice quiz actually constitute as homework points? No?
I'm not collecting it. I mean, if you want to do well on the quiz, you should probably do it.
To the third, 64.
One second.
4 to the third, 64.
Yeah.
Integral of
V of t dt. Whatever variable is here, you should always have that on the outside. Good? All right, next one. Now we actually know the velocity function, so this is a different problem. It's in meters per second of a particle moving. So how do we know when the particle's moving to the right, the left, and when it stopped? You have one like this on your practice quiz. You have one like this on your actual quiz. So what do we want to do? We want to figure out where is velocity equal to 0? We have the velocity, right? Set velocity equal to 0 and solve. So I noticed that I could factor out a 6 and actually divide. We could just divide by 6, or we can leave it. It doesn't matter. And then we have t plus 4t minus 3. So we have t equals -4, which we don't count because time isn't negative. And t equals 3. So our interval goes, basically what we have, like if here's velocity, here's 0 to 4, because that's our interval. And then we set at t equals 3. It stopped.
We don't include the one that,
We don't what?
we don't include the one that's not. We don't include the one.
Oh, the -4. Right. How do we know where it's positive and negative?
Plug in.
Just test points, right? So we got negative here, positive. So from 3 to 4, you can use parentheses or brackets, by the way. And then 0 to 3, t equals 3.
How do you know it's positive?
You pick a number. Pick 3.5.
I'm gonna plug it in if it's positive.
So 3.5, so that's a positive. 3.5 minus 3, that's positive. So positive times positive. It's easier to plug it into the factored part. It's easier to test the values.
It's just like something we've done before.
It is. We've, yeah, we've
Exact
practiced,
thing we did.
yeah.
On the-
Why is
Well,
it showing
no,
that?
because before we had to do the derivative to find velocity. Now they give us velocity and we work backwards to do, in addition to velocity, displacement and distance traveled. Okay. 4A on the next part, particles displacement. So we just talked about this. This is the integral of velocity over the time interval. You do not need to show any work except for just show me the setup and then plug it into your calculator. Do you need to see that with Math 9? Yeah.
For like the AP test, when the particle is moving right and when the particle is moving left, do we use parentheses or brackets for the AP test?
They'll take either one.
And I had a really hard time with 3C.
Okay, final position. What was final position? It's initial plus the displacement. So if you have the displacement from the previous part, just plug in 2 plus that and get negative 110.
For displacement, what's velocity?
That's it's
so
there.
it's 6t squared. plus
Perfect.
6t.
Plug that in.
How do we know it's negative 112?
I just said use your calculator. So if I do Math 9, we're going to type in 0 to 4. What was the function? It was 6x, or t squared. Then what? Plus 6x minus 72.
Oh, so it's 6x.
Listen, you can do this by
You can just
hand,
solve- yeah,
but
but-
I'm giving you permission to just write the integral and then plug it into your calculator. You don't need to go through and do this all by hand.
We do the total distance for this one. I had a really hard time with it.
Okay, total distance, what did I say? It's absolute value of v of t. So you're asking how do we do that? If, on a calculator, you do same thing, but before you start typing it in, we do math, go over to number, absolute value.
I think I was trying to do it analytically. I don't know how.
Oh, you can do that. You have to break it up into 2 separate intervals.
Exactly.
You see, so from 0 to 3, it's going to, see how here? From 0 to 3, it was negative, so we want to make sure that that result gives us positive, and then plus 3 to 4. So minus 72. And we get, hopefully, 158. Good.
But it's the same equation.
But it's the absolute value. So remember how velocity was negative from 0 to 3?
Yeah.
It ends up making it a positive. Your total distance traveled should always, it should be bigger than your displacement or equal to.
So it could be in that.
All right, next page.
No one would have thought you'd do things like that. What?
Okay, here we have velocity, but they, instead of giving us an equation, they just gave us the area between the curves. So this is this is an area of 4, this is an area of 5, this is an area of 24. So if we're talking about displacement, what do we want to do with the areas below the x-axis? Make them negative. So it's a negative 4, a positive 5, a negative 24.
Wait, this one's that easy?
It's that easy.
Oh.
How about total distance traveled? What do we want to do with all the areas that go below?
Initial.
Make them all positive. And notice displacement and total distance, we do not use initial value. The only time we use initial value is when we do like the final position, which I think is this, particles at times A, B, and C. So at A, at B, and at C. So
Oh God, I'm
Where did you get the 15 from?
it starts at 15.
Wait, don't go on.
No. So you
Do you want me to write it down?
15 minus 4
I have
equals
no
9.
idea how to do
So
this.
much to remember.
Okay, if we start at 15, at a position of 15, and we, remember, 4 goes below the x-axis, so this is going to be, I'm moving backwards 4 units, so I end up at 11. And then if right here I'm at 11, and this is positive, so I move 5 in the positive direction, so at B I end up at 16.
Should be
So
11.
And then here, I start moving the negative direction. So it's 16 minus 24, and so that's how I
So
get
A
C.
is your starting point.
No, starting point here is 15. Remember, this is on a t-axis. We're talking about time. So at time t equals 0 here, s of 0 equals 15. And then here, at A, I have 11. And then here, at B, I get 16. And then here,
The numbers are in order.
they,
Now, question. Those are the areas under the curve, I thought.
I'm not there.
those are the areas under the curve.
So why are we adding them up like this?
Because what does, guys, what are we doing? We're doing like a final, think of like final position. It's initial plus displacement. What's displacement? The integral of velocity. That was the velocity, so we want the area under the curve.
Oh, thank you. Phil.
And then where does the particle achieve its greatest positive acceleration? At A.
No.
What's acceleration?
When it is
The
a positive
steepest.
slope.
Right. Here and C. Looks like it's C. Well, between A and B, or between 0 and B, it's going to be A and here.
Can you go down?
I'm not going to ask you anything like this on the test though, or the quiz.
At 7, no 7.
I'm not going to ask a number 7.
Is this something that would be on something like the AP test though?
Yeah.
Oh.
Okay, back to this. Number 8.
You take the,
Yeah, this is just,
how do you, why do you do?
okay, so notice here, it says number of hours after 7. So how many hours is 9? 2. And how many hours is 11? It's 4 hours later. And then it's just plugging into your calculator.
That's not the answer I got.
Wait, can we think about for a
Can you look
second?
at that? Oh my god, it's upstairs.
Yeah, I posted them on Haiku.
You have to be confident.
Wait, 0.75.
That's what I don't.
And then you call them. Then we were stupid.
Then we tell you it didn't work like that.
Casey, why do you put it over 120?
Oh, so you have to be careful because it said out of a 2-hour period.
Oh.
So 2 hours is 120 minutes. Shh. And if you look at your time intervals from 7 to 7:15, so the height, the time interval length is H.
Oh, so that's 50.
why Yeah. is
H over 2? Like, you know how it's 2?
Because it's not actually
you know
2,
who else-
it's
you know who's
2
funny
hours,
as
which
well?
is 120
What?
minutes.
It's
No, but in the
Okay.
regular trapezoidal rule, it's H over 2, so why is it 2 in that? Like in the trapezoidal rule, is that the equation?
Because you have
Um,
to match the units. The 15 can't be the
No, I understand the 2, but like in the actual equation for trapezoidal rule, why is it H over 2?
No, it should be H over 2. Hold on, let me think about this.
I'll tell you who's
It's
funny.
15.
Whatever anti-Semitic Islamic mission
What? I don't think in any way that
Wait.
was racist.
No, that's. Let me come back to that, Maya. I'll come back to that.
Oh, actually, I could be right.
Yeah, I'll come back to it. Okay, this is another one. Again, number of years since 1995. So 1998 is 3 and 2005 is 10 years after. You just plug this into your calculator. So I'm going to look for just the setup and then the answer.
Three's on the three's on the bottom.
All right, next one. So
What about number 9? Are we going back?
We'll come back to that one.
This case if it's kind of farther, I'll see tomorrow.
Okay. Feel better.
Why are you going?
All right, so
I know, it's kind of looking for that.
You should have someone who got him dumped out. And so, Mom.
guys, guys, can you just stop? Okay, next page. So this was,
Wait, are we not doing 10?
I did 10
Oh, can I just see the rest of it?
later.
Oh, that's it.
Number 1. Okay, so I'm looking at the problems from the book. You had 1, 3, 5, 6, 10, 15, and 17. So number 1, find the area of the shaded region analytically. So do you see where what we need to do is we need to figure out basically 3 things. We need to figure out the bounds. Okay, and we need to figure out what is going to be the upper curve and the lower curve,
How do we know that?
because I'm telling you.
I mean, like, how do you know
Because area is going to be the integral of upper bound to lower bound to upper bound, and then it's always going to be the upper curve minus the lower curve. Okay, so what are the bounds? Right, it goes from
pi to
0 to pi. Make sure your lower bound is always a smaller number. And then what is the upper curve? Just y equals 1, so it's going to be 1 minus, what's the lower curve?
So squared it.
Sorry. And when you plug it into your calculator, you have to make sure you do that. So you're going to just plug that in. So math 9 from 0 to pi. And then 1 minus cosine dx. And that is, they got pi over 2, that's what it is. So it's 1.571. It's fine with me. You can write all of your answers just 3 decimal places, since I'm letting you use your calculators on everything. 395. Good? What's the next one? 3? Okay, same thing. How do we set this up?
we do A equals
So
integral
A is the integral. What's our lower bound?
0,
Upper bound?
1.
Oh, it's our upper curve.
Y equals
Ah, okay, hold on a sec. So there are 2 ways to do this one. One would be in terms of x, and the other one would be in terms of y. So if we're going to do y, we do right minus left versus x, where we do upper curve minus lower curve.
I like it.
You like x?
We do that.
Okay. Then I have to rewrite, so instead of x equals y to the 3rd, what would that be? Y would be cube root of x. And what about if x is equal to y squared? Okay, now be careful. It could be plus or minus, but if you look at the curve, the bound, it's really just the positive square root of x. Just be aware that sometimes you do have the entire parabola there, but that's fine. Then you may have to set up 2 integrals or just stick with y. You do have to set up one for y, just so you know. So even if you don't like y, make sure you know how to do it. Okay? I'll show both. Which one is the upper curve? Yeah, and when you use your calculator, just use 1/3, or you can. And then what's the other one? Minus x to the 1/2 or square root of x dx. Yeah, let me show you with the right minus left. I think it's, so it would be the integral from 0 to 1, and it would be the right one, which is y squared, minus the left one, which is y cubed, dy. So whether you do this one or this one, you'll get the same answer. Which they got 112.
How you figure out the right one is the right as the closest to possible.
Yeah. Like, oh, took a delay. Okay, so here it's bounded on the right and bounded completely on the left, the shaded region. All right, what's the next one?
Can you go back?
What was the answer?
1 over 12.
Okay, can you go back real quick? Here's my square. I don't think this is actually that hard. Is 1 over 12.082?
Do press fraction, press math, and then fraction. Can I erase this? We're good? Next one is number 5, right? So same thing. What's the area for number 5?
It goes from
Nice. Yeah, so what is,
negative
so negative 2 to 2, good. What's the upper curve? What's the lower curve? Good.
how do we know what?
And what's the lower curve?
We can't use right, left method.
No. Why can't we use left method? Because we'd have to solve for x in both of those equations.
Oh, that'd be extremely.
That would be a lot more difficult. You could just, so if I ask you for the setup, you don't have to FOIL, you don't have to distribute, you could just write it this way and then plug it into your calculator. Whether you want to distribute the negative, that's fine.
In the calculator, when I distributed the negative equation of y,
No, it shouldn't have.
it did, correct. And that's why I took my.
I don't know. I guess I'd have to see what you're typing in. Hopefully you get something like 128 over 15. You could write it in decimal form. And then did you do plus 2x squared? Ah, careful. Distribute the negative here. Becomes a plus 2x squared. Oh, maybe that's what, okay. So it's really 4x squared plus an x to the 4th. What's up? Yes, it would. Good. No, that's just if you want to check your answers, you can use the program. Yeah, all right. Okay, next one. What's after the 6?
Yeah.
Okay, would you do upper curve minus lower curve or right minus left?
Wait, can I see? I would do upper minus lower. Yeah, I would do that.
Perfect. So for number 6,
A equals-
what are my bounds?
A equals negative 1.
Good, negative 1 to 1. My upper curve is
Y equals x squared.
minus
Minus
number 6.
negative 2x.
Good. So minus negative 2. I probably would just make that a plus dx. And plug that in. And hopefully you get something like 22 over 15.
You really don't have to know math to be able to do this.
No, you just have to set it up.
These problems are all set up for you. I will tell you that not most of the problems are set up nicely for you. They're not necessarily shaded in. So I'll give you I actually graphed the curves for you, so it's not like you have to graph them yourself. Because it's a quiz and I wanted you to be able, I didn't want to make it too long.
Oh, thank you.
Because you'll see on the practice quiz you have to graph some of your own. On the quiz the graph will be there, but the intersection points might not necessarily be labeled. So there's at least one where you might have to use your calculator to find where they intersect.
How do we do that?
I'll show you one.
My calculator got messed up.
Uh-oh.
I used the volume.
What's the
program,
next
and
one?
I-
10.
I like you told me to quit
What number?
when I used the volume program, but now
1, 3, 5, 6, 10, 15, 17.
Okay, so we're almost done with this one.
now it doesn't. I quit
What
like you
numbers?
told me to quit on the volume program, but now it doesn't work.
40.
Uh-uh.
Wait, what was the answer to 5?
What did we do
The
tomorrow?
exercises are on.
Do the quiz. Yeah. Yeah. See,
Everyone check
Oh.
your email.
Thank you.
Okay. Number 10. So this one does not, you have one like this on the quiz where
Oh,
you
number
can,
10?
yeah, number 10. You could set this up, and actually I have you set it up two different ways. You could set it up with two different intervals. You see how the upper curve is x squared here, but then here the upper curve is x plus
We
y
do
equals
right and
2.
left.
So you could do right minus left, or upper minus lower. What do you want to do, right minus left?
Yeah, that's right.
Okay, so if it's, so then square root of y is
Zero.
equal to x. And if it's x plus y equals 2, then x is equal to 2 minus y. Sorry. So what's my integral go from?
0 to 0.
How about 0 to 1? Okay, remember,
Are we doing
if we do right minus left, everything has to be with y. So my y values go from 0 to 1. If I did x, it would be 0 to 2.
But we're gonna do.
But we're going to do right minus left. Which one is the right-hand curve? It's, but it's 2 minus y. 2 minus y. Do my click on there?
You give
So-
us the y, the equations, right?
I'll give you the equations.
Oh, cool.
what is
And hopefully we get 5, 6.
Why is it, why don't we use the 2? I get it.
So, or, I'm going to show you a different way.
Are you sure I should do it the other way?
It's going to look like this. It's going to go from 0 to 1.
Not 0 to 2.
Why is it going to 2?
No, 0 to 2.
No, no, no.
But I thought you said if we do x's.
Then you have to do 2. If you do x's,
Oh, you have to do 2.
yeah. Notice your lower curve, when you do it with x, is just 0. It's just the area
I
under the
don't,
curve.
I don't have the worksheets.
I kind of
You
like
wouldn't
that one better.
subtract it?
Okay, so you,
Yeah.
so I'm telling you, you actually need to know how to set up both. I
Why?
have a problem on the quiz where I want you to be able to set it up with 2 and with the y.
So I start it. Simple.
Simple? Good. What's the next one? 15 you said?
Wait, can we go back to that one?
I just deleted everything.
Wait, I want to finish.
Really? Actually?
Actually, yes.
Here,
I did a
have it.
screencast of it. Here.
We've done Makaraka, we've done. No, Yeah. Mava email. What?
15.
Good. Got it? It done?
Do we leave now?
You don't, if you want, I'll show it to you.
Okay, I want to finish this one.
All right. 15. So this time we have the curves.
Yeah,
What's
I'm wearing gifts. I'm gonna sleepy talk so much because we don't know today.
I know. Thursdays are a sad day. I mean, I'm sorry. I see you guys though.
Run the screen cap.
You said Thursdays are upset.
You hate us with passion, right?
I think I'm allowed.
We had in the screencast, but you said you don't like it.
Yeah.
That was what you implied. I did not say anything of the sort.
You didn't say it wasn't true.
Oh my god, I love it.
Okay.
I learned integrals a while, but
I'm
like,
recording this and sending it to Dr. Paul.
I hate integrals.
Okay.
Do you know how many times I have recorded you on screencast, Andrew? So you're gonna try to use that against me?
You tell him his case is.
Yeah, Andrew, here.
He hasn't talked about how much he hates physics in a while.
Andrew, if you're ready to talk about
He always, he always talks bad about
You
physics.
guys read the email?
Yeah.
You guys read it? This is the biggest ever.
No, it's not though.
Like they're not actually, he basically said like, I said that he's like trying to make us undo it, but like he's like doing a really bad job of it. So what happens-
Okay,
This goes against, this stays it.
yeah.
He goes, this goes against all the morals and values that we taught you guys. This is not science that make us human beings.
Really?
And not type of graduates we thought we were educated.
You're the upper
Actually, we just killed
You're the
people.
upper end.
Actually, we just like
It's never
robbed
been-
them.
How'd they,
Look, I told you guys this reason. Additionally, Ms.
We
Mosey
do
has
not
been
allow
working
or
hard on
authorize
preparing the
any
class
type of
meeting
ditch
tomorrow.
digging.
We were scheduled to prepare for
Nor
some
have we
some
ever,
class
and
first grad night.
why we are informing your parents of the fact as well.
Really, you want to
Oh, no.
They sent it to all our parents too,
Everyone's
they
stupid.
did, yeah.
How'd they know? No, they didn't.
It says, and why we are informing your parents of this fact as well. And CJ, guys, we can go to the beach tomorrow after school.
Some of us are religious and I need to be home by 5.
No, but you done it. Do it saving. Shabbat doesn't set till like 7:30. Like late, like 7 o'clock.
I need time to prepare for
We
it.
have AP.
You don't just start it, you gotta ease it.
Okay, so you're doing it?
No, you do it too. I'm doing it
We're
for the
racing.
people that aren't here.
Oh, we're racing.
So they have it on here.
I don't get it.
I still get it.
Can you talk to
Yes, you'll still get credit.
Can you talk to him? I'm gonna take Noah's phone and respond to
So,
email.
so this, in this one,
Who are you to tell us to doucheball? I'm assuming you're not ready. I'll rest with you for you.
Was that it for this assignment?
Where's the game?
Actually, not talking to class about it. Yeah, it's Wednesday night day for all. Yeah, they're doing something at school for us. Carnival event.
Okay, so base of a solid. Oh, I drew this really big graph, but it only goes from 0 to 4. So ignore the rest of the graph. We're just looking here.
Can I draw a line down?
So the cross sections are perpendicular to the x-axis, and they run from, this is y equals square root of 2x. So given the,
It's always gonna give us the equation,
right, they're always going to give you an equation. So imagine coming out of the board are squares. So like, here's one side of the square, and the square comes out of the board. And we want to find the volume of that solid. So find the formula for the area of a typical cross section. So imagine you have this. This is square root of 2x. This is square root of 2x. So what would be the area formula?
Times squared.
Yeah. It'd be square root of 2x.
Look, the shape isn't a square.
It is. It says it right here.
Right here.
So that's going to be 2x. Now find the volume. Well, volume for cross sections
Wait,
is just the integral of the area.
wait, the formula is AX equals 2X?
Okay, so there's two parts of this. One is finding the area, one is finding one is finding the area formula, one is finding the volume.
So AX equals 2X is the formula.
Yeah.
Wait, doesn't it need to be either been in the bound?
Right, so for my volume, it's going to go from 0 to 4 of 2x dx. Go ahead and just plug that into the calculator. This one isn't hard to do by hand, but
So by finding the integral of something, we find the volume.
wait, what is it?
No, it's not A,
It's
it's 15.
because this would be 2x squared over 2.
X squared.
So x squared evaluated at 4 would be 4 squared minus 0 squared, so 16. Oops,
Aww.
that's the wrong one. So we get 16. Next, now imagine that there are cross sections. Yes, I know you spelled that. I fixed it on a different copy. What if you have isosceles right triangles? So now square root of 2x is here, square root of 2x is here. How would you find the area for that triangle?
That's 1/2 each.
Okay, 1/2. The base is square root of 2x, the height is square root of 2x.
That would just be X.
No, what's wrong?
2X.
Base is 2x. Remember, it's an isosceles right triangle, so
I'm saying that
it's like a 45,
the
45.
area would be X.
Oh, so 2x times 1/2, so yes, we get x.
Sorry,
And then the volume,
I'm making myself clear enough.
the volume is gonna be from 0 to 4 of x dx. Yeah, this one you definitely shouldn't need your calculator for. What do we get?
4. No, it's X squared.
X squared over 2. Good?
I'm sorry. No, I'm not good.
You're not good. Okay.
Not good.
I forgot actually.
I wonder what's frustrating students who never have this situation.
No,
Really?
surprisingly.
How do we determine the cross section?
Where do you sign up for the colloquium?
Online, somewhere out there.
All right, can we,
Question?
yeah.
How do we find the cross section length?
It's just, so basically you look at your region, it's bounded by here. So think, what's the distance from here to here? It's just whatever the curve is.
So it will always be like that?
No, well, if you had, let's say, we had something in our notes where it was like this, so then it would be twice whatever the function would be. Okay? On your quiz, it's not, it's just the function. Your cross-section length is just whatever y is equal to. I didn't throw in anything crazy, but that's something we can work on when we do the AP. Yeah. Yeah. Okay, number 3, find the volume of the solid generated by revolving the region bounded by the x-axis, the curve y equals 3x to the 4th, and the lines x equals 1, -1, and +1. So 3x to the 4th looks like this. Just a quick sketch. And it's bounded by these lines here, and it's bounded by the x-axis. So we're basically looking at this region here. And we want to rotate this about the x-axis. So this, whenever we rotate a solid, it's going to be pi integral of whatever the radius is squared dx. The radius is going to be the curve. Now we don't have to worry, so if we had two graphs, like if we had an upper curve and a lower curve, then we would have big r squared minus little r squared, but we just have, this is our function.
Oh, it's not, oh, it's something on the next.
Yeah, so pi, our integral goes from -1 to 1 of 3x to the 4th squared dx. And again, you can just plug that into your calculator. I don't know what I did. Why is it squared? Pi r squared.
Oh.
It's rotating, so it's taking a circle. Not this one. When it's flush against the x-axis, then you don't.
I don't know if it's a little rotation. Is that really good? Why is that matter?
So remember when we did the cross sections? We said, okay, it's going to be a square, the last page. It's a square, it's a triangle. So we did, a square is the side squared, whereas the triangle is 1/2 base times height. Well, when you rotate something, what shape do you end up with? It's a circle. What's the formula for the area of the circle? Pi r squared. What is the radius? Well, the radius is constantly changing, right? It might be it might be 3 here, but it's not here, and it's getting smaller, right? So it's constantly, the radius is changing. So that's where the integral comes in. It allows us to find all the areas of all the circles there. No? Just memorize what to do then. Oh, I don't know. Plug it into your calculator. You got 2 pi? I don't know. I have this solution.
You know why this morning we just had a physics quiz with our calculator had 2 degrees?
All the people in this class, all the people in this class right now
Yes, it is 2 pi. 2 pi's right. Okay, next one. Here we have negative square root of x. And y equals negative 2. And x equals 0. So basically, guys, on the quiz tomorrow, I will provide you with the graphs, and I'll just say it's bounded by this, this, and this, and the curves will be there, but it won't be necessarily shaded. Hopefully you can figure out if it's bounded by these 3 things, where is our curve, or where is our region? It's here. So my volume, now notice this time, I'm going to rotate this. It's under the x-axis, and we're going to rotate it. So it's helpful to kind of think about what is the big R, what is little r. So we have a big R and a little r this time. The big R is the one that's further away from the axis. So we have this one. This is y equals negative 2, and this one is y equals negative square root of x. Which one is further away from the x-axis? Negative 2. So that's my big R.
I don't really know.
It's further away from the x-axis.
Oh, from the accent.
And then this is going to be negative root x.
How
So
do we know that x equals 0?
what's that? It's this whole region is rotated about the x-axis. So the outer curve, or the one that's further away from the x-axis, that's big R. The one closer to the x-axis, that's little r. So now we have to use the formula because we have 2 curves.
That's pi.
Oh, thanks. Pi.
Nice.
And we have big R squared minus little r squared.
Large question.
So we have pi. What are the bounds? If you drew it well, it should be from 0 to 4. How would you know for sure? Could you just figure out where they intersect? Yeah. Okay, so we have negative 2 squared minus negative square root of x squared dx. Now, you can simplify this. You can make this a 4 minus x. In fact, you might want to do that if you're plugging into your calculator, but you don't have to. That's all I need to see, and then you can use your calculator from there. If you're afraid you're going to mess up something when you simplify it, then
We
just
have to
leave it.
label R and
No. I'm just going to look for this, and I'm going to look for this.
I don't see how the intersect at 0.
Well, here, Andrew, it's bounded by x equals 0.
Oh.
So that has to start.
Not my jam.
Well, because I said, we talked about, well, how could you find the intersection? When y equals negative 2, what's x have to be? 4. Set them equal to each other. How do you find that where 2 things take negative square root of x and set it to negative 2? So x has to be 4. That's how we find out. I mean, that's how you could also use your calculator and just look for the intersection. Okay, last one. We have 1 minute left. Perfect. So we have square root of x. Looks like this. And y equals x. So it's like a really narrow, skinny piece. And we want to rotate this about the x-axis. Again, if you drew this well, this is 0, 0, this is 1, 0. So what's the volume? It goes from 0 to 1. What's the big R? Which one's further away from the x-axis? That's the square root. So this is big R, this is little r. So it's square root of x squared minus x squared dx. The square root part.
Little r is x.
There we go.
The R equals R equals X.
Okay, so, did everybody get a practice quiz?
Yeah.
Okay, I have a couple extra solutions if you want to take one. I'll post the solutions and I'll share with her now. I think I have one more. Oh, last one. Sorry. I'll post them on Haiku also, but I also did a screencast of myself working through the solution.
I'm taking their homework. What? This? No, the
the paper, the practice quiz,